Hi everyone, JCRTP here again. I've got a part 2 showing off the prototype of the Proteus, also known as the Rocket Pi by the avid Rocket Pool community. Last time in part 1, I talked about the physical layout of this thing and sort of how it came to be a little bit and how I modeled this stuff out, but this time I want to talk about the performance and the thermal characteristics of it, and I'll try to keep it fairly short for you. So first things first, what you're looking at here is a power meter that's actually showing how much power is pulled from the wall for this guy. And this is during the sinking process, I should add. So it's a little heavier than once it's fully synced and it's just sort of traditionally at testing normally and that kind of stuff. So the fact that it's still syncing and pulling 6 to 8 watts, I think is quite respectable. Let me pan up a little bit. I don't have any monitor capture software on here, and I do want to keep the power meter running. So I'm just going to show you the monitor and have the power meter in the background on the bottom here. Let's tilt that up a little bit more. Yeah, that looks good. Okay, that way you can keep the power meter in the corner there. So this machine comes with 16 gigabytes of RAM. You can see that here. And it has 8 CPU cores. And this is the syncing process over the last 12 hours. So I kicked this off last night, and it's been going for a little more than 12 now. But this is showing off essentially how much CPU load the system is under. I'm using Geth as my execution client, and I'm using Nimbus as my consensus client. I like Nimbus for applications like this just because it has the lowest resource footprint by far. It's using quite a low amount of CPU and it only has a gigabyte of RAM, so that leaves plenty of space for the execution client to run, which is awesome. You can see that it's looking a little spiky, the CPU usage graph, and that's just a consequence of how Geth thinks. During these sort of high moments of high load, Geth is doing its snap sync process, and then during these little valleys, it's compacting the database and sort of pausing syncing while it's doing that. And that's just a totally normal function of Geth. That's just how it works. So that's fine. But what I do want to highlight is the CPU temperature graph down here. And you can see that even during those periods of high load, this line right here represents 40 degrees Celsius, and it basically stays under that, with the exception where I had to turn the machine off and then turn it back on so that I could move the power monitor here so that you guys could see it. But 40 degrees Celsius on the CPU during syncing is quite respectable for a little mini PC like this. Most Nooks are not going to be able to get that low. Most of them are going to go higher. I'll also show off the temperature of the solid states. I've got an NVMe solid state here, and I've got this rigged up to a little script that monitors it. And you can see it's basically hanging out in the 42 Celsius, 43 Celsius range for the most part, which is actually quite cool for a solid state during the syncing process as well, because, I mean, the solid state's under a fair bit of load too. I think the only thing that's heavier than this is like the Geth pruning process. But the CPU stays under 40 for the most part, and the solid state stays in the low 40s. So all in all, I'm quite happy with those temperatures, and I think in total it's going to take about a day to sync mainnet at this point, which is pretty respectable, given the fact that you're validating with 7 watts of power during the syncing process. Once it's done syncing and you are doing like normal attestations and stuff, that goes down even further. That goes down to like 4 or 5 watts, which is really, really compelling. I'll mention real quick, since I skipped this in the first part, the solid state I'm using is the SK Hynix Gold P31, a 2 terabyte one, because this solid state is specifically engineered for maximum efficiency, both in terms of power and thermal characteristics. So I grabbed this and I put this into pretty much all of my machines at this point. I've tried a bunch of SSDs and I found that this one gives the best efficiency while not sacrificing any speed overall. So I'm very happy with it. And that's what's going to be in the Proteus for anybody that wants to grab one. Let me tilt the camera back down real quick, and I will take you on a very brief tour of how the cooling path works to keep everything nice and chill. I'm going to use the handy dandy finger hole to pop the top off. There we go. So essentially, cold air comes from the outside into this fan, which is mounted directly above the CPU, and that has a heatsink on it too. That blows on the CPU, keeps things cool, and then spreads out across and goes to the sides. And there's actually a little bit of a gap between the edge of the board and the wall of the case where air can go underneath the board. And that's where the solid state is mounted. That's just a traditional M2 2280 NVMe solid state like you'd put in any desktop or laptop. But that has a heatsink on it too. And so cool air comes from the top of the case down to the bottom, passes through the fins of the heatsink for the solid state, and then out the exhaust at the very bottom there. So there's airflow across all of the key components, and that keeps everything nice and cool. That's basically all there is to it. Sinks mainnet in about a day. Temperatures really never get above 40°C or very slightly above 40°C, and that's both for the CPU and for the solid state, and you can't argue with that. At the end of the day, you're going to be validating with anywhere between 4 and 8 watts, it looks like, which is comparable performance to the Raspberry Pi, or I should say comparable power consumption to the Raspberry Pi, but this thing is like 6 times faster from a CPU and from a solid state perspective. So it's really a no-brainer. I'm pretty much going to be upgrading all my Raspberry Pis to these things. And hopefully you guys enjoyed that and got a good view for what this is capable of and kind of what it looks like and how it works a little bit. I'm looking forward to sharing any further parts I have or answering any further questions you might have. But this is shaping up to be a pretty solid little staking box. I'm quite excited about it. This is JCRTP signing off. I'll see you guys back in the Discord.